anything, you can just direct call me lah. I give you a phone number because my phone don't have the internet access here, so I use my wife phone number. So anything you can call this number. Okay, if I lost internet connection or whatever, you call this number. Yeah, my number is with her now. Okay. Again, really so sorry for waiting me so long. Okay, so we will start now. Okay, so today we will continue with next chapter, the new chapter, is it? Chapter 4. As I said, if possible, of course, I wish to finish everything, the chapter 4 by today lah. Okay, if possible lah. But basically, the chapter 4 is numerical chapter. Okay, this is a numerical chapter, so normally involve a very long calculation. Okay, so 1 minute, yeah. And I have for the tutorial solution, everything I have already prepared the solution earlier. So if anything, we can referring to the solution lah. Okay, which we can save the time there. But of course, I want you to try also lah. Okay, 1 minute. Okay, so this is chapter 4. Before that, let me open the tutorial also. And again, because I give you late the assignment, so you are allowed to submit it to me by next Tuesday. Okay, you may submit it in the class. Okay, not necessarily this week. So sorry, because for my late. And please form the group among yourself lah. Okay, so this is tutorial 7. Okay, but we have to start with chapter 4 first. Okay, so what we see chapter 4, this is an ODE. When we talk about the ODE, okay, that means when we have dy, dx, or dx, dt, what happened there? You only have one independent variable and one dependent variable. Sorry, one independent variable, one dependent variable. Okay, so like this one, y prime equal to xy. That means your y, okay, is a dependent variable. Your x is independent variable. Okay, y prime equal to xy. Okay, that means it's like if this one is in the short form. Okay, if in the full form will be dy dx equal to xy. Okay, so what we want to do is we want to solve this one. Okay, this is called first order. Why first order? Because this one is power of 1. If power of 2, okay, power of 2, this one is no more first order. This one actually should be second order already. Okay, it's still an ODE, but this is a second order. Okay, so in this chapter, we want to study the numerical. I trust that before this, you have learned somewhere in order to solve this one. For example, in order to solve this one, we can make like 1 over y dy equal to x, sorry, dx, and then we integrate for both sides. Okay, so this one will become lone y, and then this one will become blah 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 and so on. Okay, so this is the analytic way in order to solve. Okay, analytic way in order to solve the equation, where this equation can be easily solved by using the analytic way. Then we can use the analytic way. But unfortunately, okay, a lot of the times we don't have the specific way in order to solve the analytic. On the net. Okay, because until today, okay, until today we still don't have a sufficient method to solve every ODE. Okay, so that's why you can see sometimes even they do the PhD, for example, my PhD or my master, okay, I still doing how to solve the ODE and PDE. Okay, my PhD lah. Okay, so actually until today we still don't have any how we said comprehensive way. That means we don't have any way, okay, that can confidently said, okay, I can solve every PDE or ODE then. Okay, so that's why we need numerical method. Okay, numerical method in order to solve the equation. But again, if we talk about the numerical method, normally the numerical method is not that accurate. Okay, it's not that accurate. Sometimes it's depend on how many iteration you do. The more iteration you do, okay, then it will be more accurate. But again, if you want to do more iteration, more step, that means you have to take more time. So that's why sometimes when we do this one, we use computer. Okay, we use computer. Normally we run for 1,000, 10,000 step. Okay, then for mathematician, normally we need to run for like a 1 day. Okay, even not 1 day, also like need 1 hour, maybe 1 hour or 2 hours if you use a better computer. If your computer is not that good, maybe you have to take like 1 day, 2 day in order to get the accurate answer. Okay, so this is the bad point of the I mean the not that perfect point for the numerical way. Numerical normally can solve every questions. Every equation can be solved, but need a lot of time. And again, is no one can guarantee whether it is accurate or not. Okay, so what we want to solve here is we want to solve this one. Okay, we want to solve the first order equation by given by given the condition here. Okay, given the condition normally is given the first point. Okay, what is the first point of x? What is the first point of y? So this one is called initial value problem. Okay. Again, if you have any question, please stop me. Okay, first we see the Taylor series method. Okay, Taylor series is this one. We always, when we talk about the numerical method, normally we start with Taylor series. Some people they start with Maclaurin series. Some people they start with Taylor series. Okay, no matter what kind of numerical method. Like last chapter, we also start with Taylor series in order to get the finite difference. Okay, in order to get the centered finite difference, forward, backward, and so on. Everything is regarding the Taylor series. Okay, some people they again like they start with Maclaurin series, but Maclaurin series actually is Taylor series. Okay, just Maclaurin series is Taylor series when x about 0. Okay, and Taylor series is open. We still don't know what is our x here. If Maclaurin series already said that your x must be 0, so you have yi prime x and then yi prime prime x and so on. Okay, so this is the difference. Okay, so this one the formula you can have a look. Okay, you can have a look until here. Okay, until here this is what I want. Okay, this one you can have a look. Okay, so this is the Taylor series. That means if I want to get the next point, I need to use yi prime, yi prime prime, yi prime prime prime. That means what I want. Okay, if I have let's say 0, and then next one is 0.2. Let's say lah. Okay, let's say next one is 0.2. So that means if I want to find the next point, which is 0.2, okay, which is 0.2, I need to have everything about the 0 because it's yi. But I need the differential of this point. Okay, first differentiate of this point, second differentiate of this point, third differentiate of this point, and so on. Depend on how many order you take. Okay, now we'll have a look. This example. Okay, I want to solve by using the Taylor method. Is it this one same as your knots, or different knots? Is it this one same as yours?
Same.
Same, okay. Okay, so for example, by using the Taylor method of order 3. Order 3, that means we take until here. Okay, this is 0, this is first, second, third. So we'll take until here. With a step size 0.1. Okay, and then I want to get for 1 until 1.5. Normally the initial one, the 1 will be given. So what you want to find is you want to find 1.1, 1.2, 1.3 until 1.5. So you have to do it step by step. By using the y11 here, okay, we have to find the y1.1 first. After you find out the y1.1, then only we find the y1.2 and so on until we get the y1.5. Then only we solve it. Okay, so that means you have to do for 5 times. Okay, so now let's see how we're going to do it. Okay, so first we know that our equation is this one, y prime equal to xy. Okay, then what we see, I need the y prime, I need the y prime prime, I need the y prime prime prime. So how I differentiate? Okay, I differentiate. After I differentiate again until the third order because I need until the third order. So after I have, okay, how we going to differentiate this one? Okay, I have y prime equal to xy. So if I want to differentiate this one until the second order, I differentiate the whole thing. Okay, I differentiate the whole thing. So differential of y prime becomes y prime prime. Differential of this one, I have two terms, so that means I have to use a u dv dx and then v du dx. So differentiate this one, I get 1, and then differentiate, I differentiate this one, I get 1, and then y is still there. Sorry. And then next one, I differentiate the y, so I will have dy dx. I don't know what is the y lah. So that means dy dx, that means I will have y prime. And then the x is still there. So that means I will have y plus y prime x. So that's why you see here, okay, y plus y prime x. So this is differentiate 1 times. So doing the same thing, we differentiate again to get the third order. Okay, so that means now how I'm going to get the first order? I put in 1 because 1, 1. So I put in 1, 1. So that means my y prime at this point is 1. And then I put in again, this one is 1, this one is 1, this one is 1. So that means my y prime prime will be 2. Okay, and then I put in here again. So this one is 1, this one is 2, this one is 2. Okay, so 2 plus 2, I get 4. So that means now my formula of this one, okay, in order to get the y 1.1, okay, so y 1.1, let me see, yeah, this one. Okay, y 1.1, sorry, I should not write this one. Y 1.1 actually is equal to y1. Y1 is equal to what? Equal to y0 according to the Taylor series lah. Sorry, here the table is not. Never mind. Okay, plus, okay, you refer back the formula again. Okay, you refer back the formula again is yi prime h. Yi prime h, that means it's y0 prime h. Where our h is 0.1. Alamak, what happened there? Okay, and plus again y0 prime prime and then 0.1, sorry. 0.1 square. And then don't forget to divide the 2 because 2 factorial is 2. And continue until you get the third order. So you sub in. Just now we said what? Okay, this one is 1, 2, 4. So you sub in. This one is 1, this one is 2, this one is 4. So I sub in 1, 2, 4. At this point is 1. So I can get this point. This one is y 1.1. Okay, so this one is y1.1, and then after that again, we try to find what is your y1 prime, y1 prime prime, y1 prime prime prime, and then later you sub into the formula again, you will get the y2. Okay, that means you can get the y1.2, and keep repeat until you get the y1.5. Okay, any questions here before I proceed again? Okay, I assume no questions, huh? Okay, can you try to do a question 1? Maybe 5 minutes. We do a quick one. Later I show you the answer. We'll compare the answer. This one please take note. This is only up to order 2. Order 2, that means you need to find the dy prime prime. So that means you have to differentiate one more times on it in order to get the next step. For this one, I calculate directly by using these two. I does not show up how to get the negative 0.73728. I just direct plug in and then I direct get this answer. You want also can now. You just plug in your x is 0.4, your y is 1.92. Then you should get this one. Do you get the answer? Anything you want to ask regarding this solution? If not, I will proceed to the next one, Euler method. I repeat again, this one, my soul, okay, how I get this one, I just directly negative 4 because my x is 0.4, so I will put in 0.4, and then my y is 1. Sorry, not 0.4, but 0.2. Okay, because this place 0.4. Sorry, 0.4. Let me think. Sorry, it should be 0.2. Okay, 0.2. So I plug in 0.2, and then my y will be 1.92. Oh, no space. And then square, my right hand. Negative 0.2, and then 1.92 square. So I get this one. Okay, you can try that. And then this one is you plug in y as 1.92, x is 0.92, 0.2, y is 1.92, and then your dy dx is just now what you get, 0.73728, you plug in here, then you will get the answer of negative 3.12017. Get the answer. Get the answer. Proceed. No questions, huh? You got questions or not? Any questions here? Shall I proceed? No questions, huh? Okay, I proceed. Next one. Okay, next method is called Euler method. Okay, Euler method again, what we want to solve is the same thing. Okay, first order ODE and also the Y naught X naught. Okay, what we want to find, what we are given here, and then we want to find the next step, and so on. Okay, basically we want to solve the same thing, just different method. Okay, so Euler method use a tangent line to approximate the graph. Okay, basically this is the idea what we want to do lah. Okay, we use a tangent line in order to approximate the next step. Okay, so that means if we have line something like this, and then what we do is we keep drawing the tangent line, and then we'll find the gradient of the tangent line. Okay, that means for every curve at every point there must be some tangent there, and then what we want to do is we want to find the tangent. Okay, and then by using the tangent we approximate the point. Okay, what is the y there? Okay, so this is basically when we have a very small h. Okay, when we have a very small h, your h is very small. Okay, of course it's not 0.2, 0.1 like in our example, but because if we take small enough like 0.0001, okay, then we can assume, okay, because if you follow back the Taylor series, okay, you follow back the Taylor series, this is a full Taylor series. This is a full Taylor series. When your h is small enough, okay, when your h is small enough, this one's still okay. But when you have h squared, let's say your h is 0.0001, then your h squared will be 0.00000001. So it's very small. It's very near to much near to zero. So this one we can assume. Okay, we can assume there are nothing there. It's very near to zero, so no point we'll calculate that. Okay, like most of the engineering, normally what we do is we will take more than that. Okay, so such small error or such small approximation we can ignore that, because since like, okay, I trust that if let's say you build a house, I don't know what is your field lah. Let's say lah, okay, you build a house, and then let's say don't want to build a house. Let's say we said lift, okay? In the lift, they must state there, okay, we can take approximate how many percent, how many kg, okay? Let's say they can take 24%, and then 1000 kg, they state there. But I trust that there must be, okay, more than that. The actual amount will be more than that, okay? Although state there is 1000, but actually can take 1200, something like that, okay? So it's just approximate, and to be safe, we try to take the smaller size so that the lift still can walkable. Okay, if let's say more a bit. Okay, so this is what I said. When the error is small enough, okay, since already like we use 200 kg there, okay, like this only like few like not even few grams, so we can assume it's not there. Okay, so this is if again like if let's say in future you are planning to do mathematics or something like that, then this error we will take care lah. But in engineering or in for your degree level, normally we don't care about it. Okay, we just assume it's very near to zero, so no point we'll find it. Okay, so We assume this is first of all this is the equation. This two is the equation. I just move my yi to the back, so become plus and so on. Okay, and then my yi prime. Okay, because it's given you will be given yi prime is what. So this is your yi prime. So just plug in here. So you will get the next point. Okay, you can get the next point easily by using the Euler method. So it's much easier compared to the Taylor series method. Okay, because the Taylor series method only will take to second order or third order, so it will be quite long. But this one you only need to like take first order. Okay, so now we have a look. Okay, so let's say I want to solve this one. Okay, I want to solve this one for 0 to 1. So that means I want to find, let's say I want to find the y 0.2. Let's say like, okay, y 0.2, according to the formula will be y0 plus my step is 0.2 times of this one, x plus y. X plus y when 0, so that means when 0, that means you put in here, that means it will be 0, 0. So that means this whole thing will be 0. This one y0, y0 is 0. So that means your y 0.2 also equal to 0. So we can see, okay, it's much easier in order to get the y 0.2 compared to the Taylor series. Taylor series, you have to calculate the first differentiation, second differentiation, sometimes even third differentiation, and then plug into the equation, and then in order to get the next equation. Okay, I mean the next point. Okay, so again, same thing. If let's say I want to get the y 0.4, then I have to get the y 0.2 and then plus 0.2 times x plus y. But now my x is no more 0 because your x is 0.2 already. So this one put in 0.2, but your y is still 0. Okay, and then y 0.2 is what? Is 0. So that means for the next point, you will get 0.2 times 0.2, 0.04. Okay, so this one is they're trying to separate them, like they make this one as one thing. So you just need to take this one plus this one in order to get the next one. Okay, in order to get the next one. So this one plus this one and to get the next one again. Okay, so this is basically what they do here lah. Okay, so this is called Euler method. So of course, you can see Euler method is an easy method, and this method actually is very rough, accurate only. Very rough estimate on it. So based on this method, we have modified another Euler method, okay, which we call modified Euler method or improved Euler method. Sometimes we call predictor corrector method or Hume's method. Okay, so you have to remember this all three is the same thing. Okay, again, what I want to solve is this one. It's the same thing. I just direct proceed to the formula. Okay. What is different is just now what you have is only 1 point. Now what we want to do is we approximate of 2 points. Okay, we translate on this point actually is approximate of 2 points. Okay, that means not approximate but average of 2 points. Okay, so what we do is we try to find for 2 points. Okay, we try to find for 2 points. But you may ask, I want to find yi plus 1. Then how am I going to plug in my yi plus 1? Okay, so now this is why we said chicken and egg problem. I don't have this one, but now I want to plug in this one in order to get the approximate. So it's impossible, is it? So that's why we have predictor and corrector. Okay, so now let's see. Okay, this one. I think we direct go to the example you can see. Okay, so we are given this one, and then y naught is 0, and then okay, so by using the modified, okay, what we want to find is this one. Sorry, okay, what we want to find is this one. But since I cannot get this one, okay, so what I do here is I make it as K1 and K2. And then what is my K2? My K2 is this one. I just approximate. What I do, actually this one should be yi plus 1, but I does not have the yi plus 1. So what I do is, I take the yi plus the K1 I get. Because K1 is by using the Euler method, I get some approximate of difference of my y. Okay, so what I do here is I get the approximate of difference, I put inside here. And then I find the average between the x and between the real one, not real one, by using the Euler method, and by using the average of the Euler method. So I try to average them. Okay, so now let's see. So this one basically is a more step lah. Okay, it's not like Euler method, because Euler method you only need to find the K1 and then plus your yi, then that's all. Then you will get the next one already. It's much simpler. But this one, you need to find the K1, K2, and then plus together, and then in order to get the next one. Okay, so now let's see. Okay. So for this one, I want to find by using the Euler method. Again, I want to find the K1. I want to find the K2. So what is the K1? What is your K1? H times the function. So what is your function? X plus y. So it's H, which is 0.2. Okay. By using this one is something separate. Okay. Your H is 0.2. So 0.2 times your X plus y. Okay. 0.2 times your X plus y. 0.2 times your x plus y. So for example, the first one, 0 plus, your x is 0, your y is 0, so 0 plus 0, 0, and then times 0.2, so your k1 is 0. And then what is your k2? Your k2 is 0.2 again, times your x1 plus 0.2, so that means it will be xi plus 1. Okay, so that means now it will become 0.2. Okay, this function, don't forget. So now your x is what? Your x is no more 0. Okay, your x is 0 plus 0.2, so it's 0.2. And then your y is what? Your y just now is 0, but you have to plus your k1. So 0 plus 0, so plus 0. So 0.2 times 0.2, you will get 0.04. So your next y will be what? Your next y, okay, will be y1, which is 0. Plus half times your K1 just now is 0, K2 is 0.04. So plus together, okay, this one plus this one, yeah, that's why you will get 0.02 because half times 0.04. Okay, and by using the same way, now you have your x, you have your y, you get the K1. So what is your K1 again? 0.2 plus 0.02, which is 0.22 times 0.2, so you will get 0.044. Okay, and then get your K2. K2 is what? 0.2 times your 0.2 plus 0.2, so become 0.4 plus your y 0.02 plus your K1 0.044 times again 0.2, you will get this one. And keep repeat until, okay, does it mention where to stop? Let me see. Okay, this question actually should mention your x is from where to where, but that's not mentioned. But in exam, normally will be mentioned, no worry. Okay, this one I assume is until here, let's say. Okay, because they should mention, I think it's this one, 0.2, 0 to 1. So actually should be until here, sorry. Okay, should be until here lah. That means I want to get the y of 1 is what, then we do already. No need to find the K1 and K2 for this one because the K1 and K2 is used to find the next one. Okay, so now try to do the question 2. Okay, so now we have a look. Again, if not the same as your answer, please let me know. Okay, this is by using the Euler method. What I get by using the YN, by using the Euler method, sorry. Okay, at last I get 1.214404. This one you please be careful because one of the steps is wrong, that might will affect whole thing there. Okay, and when I mark, I impossible help you to calculate. Okay, is it your next step is based on the last step? Okay, once it's wrong, then I have no choice. I must deduct your mark there lah. Okay, for the rest of the answer which is wrong, then I have to. Normally, how I mark? Maybe. Ah, wrongly ah. Let me check. Ah, okay, my mistake. Let me see. H 0.1. 0.1. Yeah, 0.1. No 0.2. Oh, this one I did wrongly. Sorry, my fault. My fault. Let me check again. Euler. Yeah, should be 0.1, but I put 0.2. So sorry, my mistake. My mistake. Okay, so sorry. Can anyone share your answer? And then I direct check from your answer. This one should be 0.1, but I put 0.2, my mistake. So sorry. This one should be 0.01. Okay, and then this one should be 1.01. Let me see. So sorry again because of my mistake there. I direct check here. I direct check this one. If okay, you may proceed to the B first. I check this one first. So sorry, my mistake. Okay. 0.1, 0.01, 1.01, 1.01. So 0.1 times 0.2 times 1.01. 0.0202. Correct. Okay. And then it should be 1.01. 1.01 plus 0.0202, so 1.0302. Okay, and then 0.3 times 1.0302 times again 0.1. So 0.03091. Okay, round already. Okay, can. So 1.0302 plus 0.03091. So 1.0611. Okay. And then 0.1 times 0.4 plus 1.0611. Plus times 1.061. 0.04244, correct. Okay, so the next one will be 1.0611 plus 0.04244. 3, okay, correct. Okay, so up to this point, correct. This one no need, This one no need to calculate because you are not going to calculate the max 0.6. You are only calculating to this point. So this one no need to calculate. But up this one, everything is correct. Okay. So sorry for my mistake. Then I think the next one I also did wrongly. Okay, this one is correct. This one I think correct. So now let's see. This one up to here lah, up to this point. Okay, compare your answer with this one. Again lah, because this one is modified Euler method. Okay, modified Euler method, we need to find the K1. And after you find the K1, you have to put into here in order to get the K2. So by using the K1 and K2, only you can find the next one. Okay, so let's see. But I take this two steps as an example. So for K1, for the step n equal to 0, so my xn will be 0, my yn will be 1. So 0.1 times 0 times 1, I get 0. And then after that, I put in, okay, this one is my h, is 0.1. So 0 plus 0.1, so this one is 0.1. Okay, and then this one will be, okay, 1 plus my K1. My K1 is 0, so it's 1. So this one is 1. 1 times 0.1 times 0.1. So I get 0.01. Okay, 0.1 times 0.1, I get 0.01. So I have 0, I have 0.01, and then I put in here. So 0 plus 0.01 times half, I will get 0.005. Okay, 0.005 plus my yn, which is 1, so 1.005. So this is my y1. Okay, so I have my y1. Again, I put in my xn, yn into here in order to get the k1, which is 0.01005. After that, I put in here again and here again. Okay, this one now is 0.2. Okay, so this one will be 0.1 times 0.2 times again your yn 1.005. Okay, plus your k1. So that means it will be 1.01505. So after you times in, you should have this one. So you take this one plus this one times half plus again this one, then you have this one. Okay, that means it will be this one plus this one times this one times half. This one plus this one times half. Sorry, then you have the next step. Okay, so everything you list down, then will be easier for you to check if you have time. Okay, so is it same as your answer? So, any questions before I proceed to the third one? Okay, so I think the yn plus 1 equation is fixed. What you mean? The yn plus 1 equation is fixed. You mean for this one, is it? You mean for this one, is it? The formula is fixed. The formula is always yn plus 1 equal to this one. Just y difference because the yn, xn, yn is different. It will be changed, always change. Okay, but the formula is still the same. No matter Euler method or modified Euler method, the formula is always the same. But because of modified Euler method, your K1, K2 will be changed. So that's why your yn plus 1 also will be changed. But the formula is set there, it's always the same. For every question will be different lah, but for modified Euler method, always this formula. But for Euler method, not necessarily must be this formula. It depends on what is this. So every question will change, but in the question, always will be the same. Okay? Am I answering your questions? Because I'm not so understand. Oh, okay. Yeah, okay. So I proceed. Okay, so the third one, they ask us to compare, okay, they ask us to compare the answer in A and B, okay, obtaining in by using the separation variable. So that means actually this one I can solve it easily by using the separation variable. Okay, how? Again now, y prime equal to xy. So that means my dy dx equal to xy. So I move my y here, so I will have 1 over y dy equal to x dx. So I integrate both sides. I integrate both sides, I will have ln y is equal to x squared over 2 plus c. So everything exponential. So I will have y equal to a, because e power of c is a, okay, a and then e x squared over 2. And then by using the questions given, sorry, not this one, by using the y0 equal to 1, y0 equal to 1, so that means 1 equal to a. A e power of 0 is 1 lah. So a is 1. So that means my equation actually is y equal to e x squared over 2. This one you should learn before lah. Huh? Okay, so I just briefly go through. So by using the y equal to e x squared over 2, okay, y equal to here, okay, y equal to e power of half x squared, okay, y equal to e half x squared. So I put in, okay, this one is called exact. Exact, that means I put in, I want to find this one, okay, I want to find this one, then I put in my x, my x is starting with 0, okay, my x is starting with 0 and the difference is 0.1. So that means this one is 0, this one is 0.1. 0.2, 0.3 and so on. So that means I put in, for this one, I put in my x as 0, so I get 1. This one, I put in my x as 0.1, then I get this one. This is when I put in as 0.2 and so on. This is 0.5. So this is called exact one. Exact, that means your accurate answer. Okay, your accurate answer. So you will see, because this Euler method actually is a very simple method. So the more you do, okay, the more you do, you will see their difference will be more difference. Okay, and normally because the Euler method is not a very good approximate method, this is just a very basic method. So we'll see the error of this one. That means the error of this one and this one, the difference between the exact one and the what we approximate. Okay, the error between what we approximate and the exact actually will be greater than, will be much greater than what we approximate by using modified Euler method. Modified Euler method is a slightly better method compared to Euler method, but it is still not a very good method. Why we say so? Because you can see, as you proceed, okay, as you proceed, the difference is getting bigger and bigger. Although the speed of getting bigger is very small, but it's still getting bigger and bigger. So let's say you want to do until like 100 steps, then it will, the error will become cannot be negligible anymore. Okay, it will be significant already, your error. So we can, this too is not a very good method, but it's a very basic method lah. Okay, this is a starting of our numerical method, so that's why we learn here. Okay, so this is called error. Error, that means we try to compare with the real number. Okay, we'll try to compare to the exact number, so you will see the difference. Okay, so any questions for this error? If no, I want to proceed again to the ranch footer. Any questions? This one will be wrong lah. This one should be wrong lah, because this one I calculate by using the 0.2. So some mistake there. You just take your answer minus the exact answer, then you will get the error already. But no matter how, the error of this one should be greater than this one. So that means, okay, if you want to comment, that means the modified Euler method will be a better method compared to the Euler method, because the error is smaller, much smaller compared to the Euler method. Any questions? Yes. Depend on the questions, because these questions asking about this one, They ask us to compare the answer with the actual value. So that's why you need to find the error. If the question doesn't ask you to find the compare, then you don't need to find the error. But if not mistaken, I can't tell you so much lah. But if not mistaken, I don't ask you to find the error lah. If not mistaken, but somehow you still try to remember how to do lah. Because I also can't confirm. Quite long time submit already. Few weeks already. Okay. Okay, so I proceed. If you have no questions. So next one will be Ranch Scooter. Ranch Scooter is a very famous method. Okay, it's a very famous method. Until today, we still assume Ranch Scooter actually is a good method, even though we have a lot of numerical method already. But until today, even those for doing the master, okay, PhD very seldom lah. But like even they doing the master, they still compare to the answer obtained by using the Ranch Scooter. So actually, we assume the Ranch Scooter until today is still a very stable method. Okay, not like Euler or modified Euler method. Okay, but Ranch Scooter is a very long method. So you want to do one step, need to take a lot of time. Okay, so we have a look. Ranch Scooter we have two types. Okay, actually more than that lah. But for here we just look at two types. One is order of 3, one is order of 4. Okay, so what is the difference? If order of 3, you need to find the K1, K2, K3. Basically, Ranch Scooter is something even we modified again the modified Euler method. Okay, modified Euler method is already something is modified from Euler method is something improved already. But now Ranch Scooter is again the improve again. Okay, because what we see, even the modified Euler method is not a stable method. Okay, it's not a stable method. The more you extend, the more step you extend, the bigger error you will get. Okay, so here they have a Ranch Scooter method. Okay, in order to reduce the error. Okay, so that the method is still stable. They try to stabilize the method. So no matter you do how many steps, the error is not that big. Okay, it won't like you do until 1,000 steps, then the error is until like very big already. Okay, until like we cannot neglect it anymore. Okay, but Ranch Scooter we try to still stabilize the error, so the error is still there. Okay, the error is still there, always still there, because numerical method we won't get the exact answer. Okay, but what we want to do is we try to stabilize the difference. Okay, so basically this is a formula. Okay, here I don't want to. Basically, is again lah. It's come from the Taylor series lah, but I don't want to show you how to get already lah, because this one actually is given. Let me see. It's given or not. We try to partial paper. Way to get partial paper. Let me think. Let me see. Do I have? Okay, I take the last year one. I can't remember where already. I think there should be some formula, but I can't remember. Let me see. Oh, recently I think a lot of students like they are signing the petition in order to ask to do the final exam by online. Is it? Do you sign it? I don't know lah, but I saw the news. They said some people they try to like gather the signature and everything, so that they can have the online exam. I don't know lah whether you sign it or not lah. Seems don't have but if not mistaken about the formula, let me check again. Okay, I'm not sure. Okay, I'm not sure whether it's provided or not. But if not provided, that means you have to remember lah. Okay. So this is a formula for order 3. You need to find out K1, K2, K3. Okay, basically they are the same as a modified Euler method. Okay, that's why it's different is you have to calculate more times. Okay, and also K1, K2, K3, K4 for order of 4. So that means you have to do that. Okay, so now we'll have a look on the example. I want to solve by Ranch Scooter method of order 3, and 4 by using the by this 2. Okay, so by given this one where the range is from 0 to 1. 0 to 1, the H, the stack size is 0.2. So that means I have to calculate 0 is given, okay, but I have to calculate 0.2, 0.4, 0.6, 0.8, and 1. Okay, I have to calculate for 5 times. Okay, so that means, okay, I have this one, and then by using the run scooter, I have run scooter of order 3, I have this one. Okay, so what I do here, okay, let's say I do the first step lah. The first step, x0, y0, so I put in 0, 0, so my k1 will be 0. After you get your k1, then you can get this one. Okay, this one now will be 0 plus 0, so still 0. Okay, 0 plus 0, still 0. And then this one now will be 0.1. So 0.1 plus 0, I will get 0.1. 0.1 times 0.2, I will get 0.02. Okay, and then you keep continue lah. This one will be 0.2, and then this one will be 0 plus 2 times k2, which is 0.02. So it will be 0.04. 0.04 minus the k1, which is 0. So you will have 0.04. 0.04 plus the 0.2, so it will be 0.24. 0.24 times 0.2, you will get 0.048, which is this one. So after that, we can calculate this one. This one will be 0 plus 1 over 6 times this one plus this one times 4 plus this one. So you will have this one. Okay, so just keep continue. Then you can get the K1, K2, K3, and the next one. Again, because what we want to get is a 1.0, so we just stop. We just stop until here. Okay, for this point, you don't need to find the K1, K2, K3 anymore because the K1, K2, K3 is used to find the next one. Okay, since we are not going to find the next one, so we just stop here. Okay, so order of 4 also will be the same, just different of the formula. Okay, just different of the formula, so you just put in the formula. Okay, this one is 0, this one is 0, so 0.2 times 0, so K1 you still get the 0. And then K2 it will be 0.1 plus 0, 0.1 plus 0, so it's 0.1 times 0.2, so you have 0.02. Okay, and so on lah. Again lah, just follow the formula. As long as the formula is correct, there should be nothing wrong. Okay, if let's say you don't want to use this one, you can always change it to like, okay, K1 easily to check lah. This one is equal to 0.2 because I know the function actually is plus, so it's xn plus yn. You can put into something like this, and then your K2 is what? Your K2 will be 0.2. Okay, times what? This one plus this one. So you don't need to put the function there, and then you have to check back what is the function again and again. Okay, but basically the idea is the same. Again, you do until the 5th set, then we stop there. Okay, so now your turn to try the questions number 3, sorry. Try the question number 3. Again, maybe another 5 minutes. Question 3, you only need to find the 0.2, 0.4, 0.6, although it's only 3 steps. But because you need to do the order of 3, that means you have to calculate the K1, K2, K3 for 3 times. If order of 4, that means you have to calculate the K1, K2, K3, K4 for 3 times. So that means like a 12 step already if you compare to the normal Euler method. Okay, but again, the more step you do, the answer you get, if you compare to the exact answer, it will be more accurate. The size of the error will be getting smaller and smaller. Okay, order of 4 will be getting smaller than order of 3. Order of 3 will be getting smaller than modified Euler method. Modified Euler method will be smaller than Euler method. Okay, so the more step you do, the answer will be get smaller. And in the real life, we don't worry about the work we have to do a lot, because what we do, we just set it into the MATLAB. I think you learned MATLAB before lah. Set into the MATLAB or set into the Mathematica or Maple, something like that, and then they will calculate automatically. Just sometimes take a lot of time. Okay. Here, in order to illustrate the method, so we will do it manually. So we try to take the H is quite big, 0.2. In the real life, we won't take big like that. We will take like 4 to 5 decimal. Okay. Okay, so I trust you have done the order tree. Now I show you the answer for the order tree. Then you compare. This one is order 4, this one is order 3. Okay. Any error, please let me know. You see this one, they put in the function already. They don't put f or blah blah blah. Okay, they just direct put in the function already. So they don't have the f anymore. This is why I tell you the sound. Not necessary to put the f there. Sometimes f you have to refer back. The formula is very troublesome. You put something like this, then you just plug in plug in your answer, plug in your K1, K2, and then you can direct get the answer. Will be much easier. If okay, then proceed to the order of 4. Okay, this is the order 4. Basically, you can see the order 3 and order 4, the difference is not big lah, huh? Okay. But again, the more step you do, you will see the difference is getting bigger and bigger lah. Okay. At first, maybe just like fifth and sixth decimal is a bit different, but until the third step, like third decimal, fourth decimal is already different. So the more step you do, the more step you extend, the error is bigger. Okay. Sorry, now I only saw how we get yn equation to C. Sorry, now I only get I only saw your message to C. Yn. It means this one, is it? This is no matter this one or this one is based on what we calculate. This is what we calculate. This is by using the Euler method. This is by using the modified Euler method. This is what we calculate lah, by using the formula here. Okay. It has only order 3 and order 4. For your level, we only have method order 3 and order 4. Okay, of course we have more than that, but it's not necessary for your level because the error is very small. Okay, like order 4 is already comprehensive. Okay, the error is very small already, so no need to up to order 5. Order 5 normally is for the research purpose. Then only we will consider order 5, higher order lah, I mean. Okay, so for your level, we only consider up to order 4. Branch footer, order 4. Okay. So this is order 4. Is it same as yours, or you need explanation on that? Okay, I proceed again. So, again, any question, please stop me. Okay, so we not only can use the range footer to solve one equation. This one is we want to solve one equation and one condition. Okay, by using the range footer, actually we also can solve two equations by two conditions. Okay, that means I can get the y, I can get the z. We assume that y and z is based on the x lah. Okay, we can get the y, we can get the z by the system. This one we call system. Okay, we can get the y, we can get the z. Okay, so again we also have order of 3, we also have order of 4. But unfortunately, because this one we have two dependent order, we have y, we have z. So that means, okay, let's say this is y is f, this is for g. Then for K1 we will have for f, we will for g. K2 also the same. K3, oh sorry, here, K3 also the same. So that means now you have one more times, okay? That means just now you have 6 equations, now you have 12 equations. So it is very complicated in order to solve a system. Okay, not so complicated lah, but very long. Okay, so but basically the idea is the same. Okay, the idea is the same. Just because you have 2 equations, so that's why you have 2. That means now you have yn, you have zn. That's how you only need to consider xn, yn, but now you have to consider zn. So that's why you have F, you have G, so it will be double out. Okay, the more the work you have to do is double out. Same here for order 4. Okay, K1F, K1G, K2F, K2G, K3F, K3G, K4F, K4G. So that means you will have more work to do. Okay, but basically the idea is the same lah. Okay, you can refer to the example here. Okay, I just briefly go through the example lah, since the idea is the same. Okay. But no worry lah. Normally, if in exam, if really come out a system equation, I won't ask you to do until so many steps lah. Okay, I try to reduce that. If the normal one, maybe like you still have to do like 4 steps, 5 steps. But if let's say I come out this one, maybe 2 steps only. Okay, not so much. Okay, not that much. Okay, so now have a look. So your x is 0 until 0.2, and the step is 0.1. So that means 2 steps already done. 0.1, 0.2. You no need to do so much. Okay, you need to calculate the K1, K2, K3, K4 for 0 and then 0.1 and then done already. So there are not so much of steps to do. Okay, because we know that in order to do this one, you have to double the work already. Okay, so you have this one is a function of f, this one is a function of g. So we want to find, we are given y0 is 1, z0 is 2. So same here, we just list down. Okay, we just list down whatever formula we need. Okay, again lah, you don't want to put f and g here, you can direct substitute by g is this one, f is this one. Can also, no problem. Okay, just because this one is plus and minus, so it will be quite long. Okay, but basically the idea is the same. So first you need to calculate the K1F. K1F you just plug in your xn start with 0. Okay, your xn start with 0. And then your yn is 1, your zn is 2. So plug in everything. So 0 plus 1 plus 2, so it's 3. 3 times 0.1, so your K1F will be 0.3. So you keep continue until you have done this one, then you can get the next yn. So you have next yn, you have a new xn. Xn is always plus a h lah. So you have these two, then you can continue calculate for this one until you get the yn and zn for this step done already. Okay. So maybe not so clear if we just talk like this. Okay, you try to do the question 4 first. Okay, if anything not understand, let me know. Try to do a question 4 first. Okay, so I show you the answer for question 4. Okay, so this is the answer for question 4. Okay, basically, this one is x, y depends on t. So we need to find the x and y. Okay, starting from 0, you look at the questions because it's 0 until 0.2. So that means you need to use a 0 in order to get the K1, K2, K3. And then you use a 1 to get the K1, K2, K3 in order to get the 2 and then stop. Okay, 0.2. So that means you have to do for 2 times. So you have to do for 1 times, 2 times. But because this is a system, so you need to calculate for 2 times, K1, K2, K3. So that means you have to calculate for 6 times. Okay, and again, you have a look. This is what I mentioned. They already make into the equation rather than still left the f there. Okay, if you just left the f there, then later it will be difficult for you to plug in again. Okay, taking a lot of time to flip here, flip there. So instead of this one, we try to put in the formula. Put into the formula. Don't put the F there or G there. Okay, it will be trouble for you if you put the F or G there. Okay, but if you want can, just a bit trouble lah. Okay, so this is a formula. Okay, I have K1x, K1y, K2x, K2y, K3x, K3y, and I have the next x, the next y. Okay, so we just plug in first. We try plug in my x0, y t0, x0. So and the y is 1. So this one will be 0, 1, and then plus 0. So that means this one whole thing will be 0. Okay, so that means your K1x will be 0. And again, for this one also will be 0. So times 0 again, so your K1y will be 0. So keep repeat, you just plug in whatever you get K1x here, K1y here, and then your Tn is the one you need to consider, like you just plus the what is the what is the state what is the step size, so just plus in again, then you will have your t here. So by using the same way, okay, taking the K1x, K1y, K2x, K2y, K3x, K1, K3y. So by using the x here, you can get the next x. And also the y, K1y, K2y, K3y here, you will get the next y. Okay? But you cannot say like, oh, I just calculate the K1x, K2x, K3x in order to get the next x, because it might need the y, okay? In order to get the K3x, you need the K2y. So that means everything you have to come in pairs, K1x and then K1y. Then only go to K2x, K2y. Okay, cannot K1x, K2x, K3x, and then K1y, K2y, K3y. I know the function is keep changing, so it's like quite confusing, but you have no choice. In order to get the next one, you need the K1y. Even though you want to get the x, but you need the y as well. Okay, so you have no choice. You have to like keep changing the formula. Okay, so have a look and please tell me if anything wrong there. Okay, any questions there? If no questions, I'll proceed again. Okay, I'll proceed. Okay, so this is with AND order. Okay, just now what we do is a first order. No matter it's a single equation or system of equation. Okay, what we have is a first order. But now let's say we increase the difficulty into the n order. That means we can up to n order. Okay, so that means now our ODE will become something like this. Okay, up to how? Let's say your order is 3, there will be third order. Third order that means you need 4 equation. Okay, why not? Y2, Y3. Okay, so you need the 4 equation in order to get the things there. Okay, so this one now what we do is we're trying to reduce it. Okay, we're trying to reduce it. Let's say you have n order, then what we do is we're trying to reduce it into the n minus 1 order. Okay, so I have z1 is y prime, z2 is y prime prime, z3 is y prime prime prime, and so that means we don't want to like prime prime prime. We try to make it into the z, so it's a new variable. Okay, so now we have a look at. Basically, this is the idea lah. This is the idea. Y prime will be Z1, Z1 prime will be Z2. So that means now you will have less order, but with more variable. Okay, just less one order, but with one more variable, because now you see Z1 prime will become Z2, Z2 prime will become Z3. So you will have less order. Okay, so now we'll have a look. Again, we try to use a round shooter. What we do here basically is we try to make it into like still in the first order. Okay, let's see lah. Okay, we want to use a round shooter method of order 3 with a set step size h equal to 0.2 to obtain an estimate value of y 1.2 for the following and initial value problem. Okay, so I have this one. So that means now I have